photography.
Nice. See, if you fight for it, you get it. Let's do it. What we were talking about last week was fifth roots of unity, or the roots of unity. Now, with roots of unity, I think we get it. Generally, would you say we can solve for r, we can solve for theta, we can solve for z? So theta equals 2k pi plus phi all over n. Most important thing, keep your, where are we? Keep your, whatever you're trying to find in mod arg form. So -1's wrong. It should have been z cubed equals 1 cis pi degrees. Pi because it's at -1. Sounds good? And then now you know what phi is, you know what your A is, whatever. All right, easy. I'm trying to find the link between omega and z's, and that's really important. So omega, there's a lot of them. Actually, with homework, did you guys have any problems? I gave it to you with solutions to hopefully help you. But
2 and 3i.
question 2 and 3i, I'll make a note over here. We'll do it at the end as well. Question 2 and 3i, no problem. All right, so let's have a look at omegas. Yeah, something like prove that omega is a non-real cube root of unity, then this. Prove that if omega is a, that's a good question already. So prove that if omega is a non-real, which it usually isn't, right? It's complex, so don't let that word confuse you. Cube root of unity, that means omega to the power of what? 3 cubed. 3 is equal to unity. Sorry?
Is it Z?
No. Unit circle 1. Omega cubed actually equals to 1. What does that mean about omega to the power of 4? What do you guys reckon?
1 plus root 3.
1?
Wait, 1 plus.
You're so close. I think you're trying to say this. Omega to the power of 4. Sorry?
1 plus omega 3.
Not 1 plus. It's omega times omega cubed, which is omega times 1. Which means omega to the power of 4 is actually omega. What about omega to the power of 5? Is omega what? Yeah. And what about omega to the power of 6? Omega squared, cubed squared, I guess, which is just 1. Cool? We need these. Now, you ready?
It's
Sorry?
like I.
It's like exactly like I. Yeah, absolutely right. Let's go. So we need that logic because it says prove that if that's true, then this equals 16 omega. Let's see. 1 minus omega plus omega squared to the power of 4. Obviously, what are you going to do with your left-hand side? You're right. Hold on. I'm just going to screenshot it. Because obviously I won't have room there. You know what the last question was of extension 2, man? Was, you know, reduction formula? You know, those ones that were sine. That was the last extension 2. I'm like, what? What? So easy. Like, I've given you guys that just as a, here, have it for breakfast. So it's good. It's good. I'm trying to say it's good. Like, that means all the questions I've given, that's what I was looking at, making sure, am I going good? Extension 2, we're good. Advanced, I probably need to do a little bit more of standard math, and same thing with standard math. I got to do a bit more advanced math, which is just weird. I'm probably never going to teach those two after you guys. That's it. I'm only going to stick to extension 1 and extension 2. It's done, because those are just too weird. Common content. All right, back to this anyways. Look, what you said is right. I do want to make a quick point. Maybe we'll talk about a few things. Let's talk about a little bit more about omega, because omega is pretty big. So let's just keep going with omega before I continue with this question. A few interesting things that you want to link. We said omega cubed is equal to 1. That also means omega cubed minus 1 is equal to 0. that also means, it's okay, that also means if I was to factorize this, it can actually be factorized like this. All the time. So in fact, if I've got anything like this, does someone want to give it a shot? What they think it should be following this pattern? So if that means if omega was a fifth root of unity, which is omega power 5 equals to 1, and then essentially you get this, and then you'll get this, and then you end up with omega to the power of 4 plus cubed plus squared plus omega plus 1 equals. That's a really important result. Questions?
You got that from Omega.
5 minus 1, I factorized it. I'm showing you how you can factorize those without, I guess, factorizing technically. You need to know those properties. They will be helpful. Any questions at this stage? Okay, so usually you would conclude omega is equal to 1. Sometimes they say that omega is not real or can't equal to 1, and that's fair enough. And like this case is saying it's non-real. So that just means omega can't equal to 1. If omega can't equal to 1, what do you definitely know this must equal to? This whole thing.
Or just what's wrong?
This must specifically equal to 0. See, before when we had like two brackets, before, I'm going to rub this out, but just before, we had this. What did you conclude? X must equal to 2, or X can equal to -5, or let's call it or and. So or it can be, or and it can be. But in this case, if I'm telling you that hypothetically, if you ever see it, it's not a big thing, but if I tell you omega can't equal to 1, that just means this is never 0, which means this guy must be 0. It's a fact. Cool? Anyways, I think you guys don't need to emphasize that too much, so don't stress. But essentially what I'm saying is from this bracket, we end up with this. Fair enough? Then isn't it also true that I can conclude, I don't know, omega squared is equal to, I don't know, -1 minus omega?
Yeah.
And whatever. You can end up with a lot of different results, right? Still good? Any questions? Have I missed anything, Sammy? Have you missed anything? At this point in time, I told you guys how to do it if it's higher powers. I told you this. We need to learn how to prove these. Okay. How to prove 1 plus omega squared equals 0. What if I just came up to you and I said, prove 1 plus omega squared equals 0? You can't. It's proving. So what you're going to do is use your series and sequence formulas, which you haven't started yet. So therefore, you just have to learn right now. The formula is S of n equals A Rn minus 1 over R minus 1. A is first term. R is your common ratio. So what's your common ratio? What's it going up by? Or what's it multiplying up by? W or omega. Your first term is 1. N is the number of terms. Number of terms. Which equals 3. So essentially the sum, this is called sum. The sum of your 3 terms, S of 3, sum of 3 terms, is equal to omega cubed minus 1 over omega minus 1. Yes? But then the question would have said omega cubed is equal to 1. It would have said omega is a cube root of unity. Right? Like I did up here. So what does omega cubed equal to? 1. So therefore 1 minus 1 over anything is? You just proved that the sum of 1 plus omega squared is equal to 0. That's method 1. Method, well, let's call it method 2, because method 1's up here. Method 1 was, you can just say these guys are equal to 0 just by factorizing this. So method 1, method 2, there's like 5 methods, but I do the second method. Just because I think it works well, but you should know the first method because it works well for other questions where we need to equate. I think I'm happy now with omega. I think that's it. That's everything I really needed to talk about today. The rest, we're going to do a lot of questions now. Cool? So let's do it. Does anyone have any questions before I rub a lot of this out? Done. We'll do questions. I'll show you my exams on this. And you'll see how they work. Rub that out, rub all this out, and let's get going. So it said that omega is a cube root of unity, then this. Well, now we know two things. We know we can do what Mariette said, which is expand, but we also know that omega cubed equals to 1 has, like, it's deep. It's not just omega cubed equals to 1. So what we could also know from that is what we had written before, right? Like this or the other version, if it was decreasing. So then you end up with this result, which means what about 1 plus omega squared? What can you conclude straight away about 1 plus omega squared? It equals to negative omega. So that means from your left-hand side, instead of expanding this whole 3 terms, power of 4, it can be now negative omega, negative omega. Look how much easier that looks all of a sudden. That just becomes negative 2 omega. 2 to the power of 4 is 16, omega to the power of 4. But what's omega to the power of 4 equal to? Omega to the power of 3 times omega. And that is the proper way of doing these questions. Boom. So you shouldn't have needed to actually expand power of 4. The only time you're ever going to do a binomial expansion like that is in binomials or trig. You know, the equating trig, the one that we were doing last week?
Yeah.
Cosine and that one. That's the only time you're ever going to do binomial expansion. Otherwise, you should never do anything like 4, 5 like that. Done. That wasn't too bad, was it? Well, you know those two rules, like those two things. You need to know them. So let's go. Let's do a few more. Here. Here's another one. Here we go. Again, if omega is a non-real cube root of unity. So again, if omega cubed is equal to 1, prove 1 plus 1 on 1 plus omega minus 1 on 1 plus omega squared is equal to that. Okay, how are we going to do that?
Okay.
4:30 to 7:30.
Okay.
Thursday won't work. No, Thursday won't work. Has to be tomorrow. What? W cubed is equal to 1. All right. Well, what do we know again? Straight away, give me some things that you know. Sir, I didn't hear you.
I was just thinking to common denominator.
Common denominator for here?
Yeah.
Yeah, fair enough. Let's do that.
Have the boys told you that they could be late?
No.
Okay.
I don't know. What time is it?
6.
Oh, they'll probably be. No, let's have a look. Let's make it a common denominator. 5 minutes late. 5 minutes late. 1 plus, I think common denominator is not bad. Yeah, let's do that. Minus, use brackets, right? 1 minus omega if you don't use brackets otherwise. Common bottom is this. Okay, now what? 1 minus 1 is gone. You end up with this. Come on, tell me, now what? Don't say I would have expanded. Oh, would you expand? It's up to you, actually. What would you have done? Seriously. Expanded, let's do it. It doesn't matter. That's what I'm saying. Just tell me what you would have done. 1 plus omega, sorry, 1 plus omega, that's right. 1 plus omega plus omega cubed plus omega.
You could factorize the top and then cancel.
You could factorize the top and then cancel.
Yeah. No.
No, you can't, because you get omega and then omega minus 1.
Unless you do.
430? See. Okay. What is something that you guys haven't written up here, let's say? It's got nothing to do with this question. It's got to do more with this, that I think you should write. That might guide you a little bit more.
Mega cube minus 20%.
Beautiful. And then keep going. That's more for you. Keep going.
Mega minus 1.
That's,
brackets.
again, not as important. This is the important one.
Mega squared.
That's plus omega. Just keep decreasing until you get to 1. That is super important because that gives you a relationship between omega squared and omega and 1. So like you can see here, you don't have any omega squares. You need to introduce that somehow. So let's just leave it here for now. There. All right. Go back down here. What's omega cubed equal to? 1. 1 plus 1 is 2. Omega 2. So we got this right now. 2 plus 2 omega. If I haven't done anything wrong. We're getting close. I just don't like the fact that we've got 2 plus 2 omega at the bottom, but what can you do? Now,
Rationalize it.
we're going, you're not going to rationalize, not for omegas. Good idea, but no, it's not, there's no I, let's say. All right, but that's okay, whatever. All right, what do you think you're going to change? Out of all 4 of these, 1, 2, 3, 4, which one? Omega squared. Omega squared equals minus 1 minus omega equals minus 1 minus 2 omega on 2 plus 2 omega. Something's weird. Something is weird, Sam. Sorry?
You need to get rid of the denominator.
Yeah, but no, something's not working out, is it? Let's have a look. Did I do a mistake somewhere? 1 plus omega squared minus 1 minus omega. 1 minus 1 is gone. Omega squared minus omega. 1 plus omega, 1 plus omega squared. Omega squared minus omega on 1 plus omega squared. Idiot. Plus omega cubed. Okay, that's better. Sorry, guys. You meant to double check. You know I do mistakes. 1 plus 1 is 2 plus omega squared plus omega. Now, what can you say omega squared plus omega equals to? See how I changed that now? Why should I make it omega squared equals 1 minus omega? Be smarter, make it omega squared plus omega is equal to -1. 2 take away 1? 1. And I think we can see we all have it. 1 plus 2 omega. Not hard. Just silly mistakes, but you got to know the mechanics of it. Azra, you all good with that? Make sense? Beautiful work. Yes.
Where'd you get the minus 2 omega from?
Where did I get the -2? Because omega squared was what?
Okay, never mind. You used 2 different things.
Yeah. My omega squared was -1 minus omega.
Yeah, but then the bottom.
So then the bottom I just used the other one. I mean, you could have just used omega squared, and then the minus omega and the plus omega would have cancelled out anyways. That's true. It would have cancelled out, so it doesn't matter. Yes, 100%. Because very poorly done, I would have to say. But I think if you follow those two rules, you can see it's not that bad. But very poorly done. A lot of people get unity and they completely ignore omega. I'm happy with that. If we're done, I might just take out my question. Converting rectangular, that's appendix. All right, done. We're up to locus and thing, but before we do that, I'll stop this recording here and then I'll start it again.